of the solar window is all the possible locations of the sun throughout the whole year. Okay. Notice now, now you have, so far, you have developed your solar window, you have your solar paths, sun paths, you have the maximum number of peak hours that you have. You can pretty much, with this information, generate what? The whole amount. You know your module. The only thing you don't know is what? How throughout the year the environment will change. So your calculations that you're going to get up to now, it's going to be basically what? From all the data that has been accumulated for you over the period of years. But you still don't know what kind of a winter we're going to have or what kind of summer we're going to have. All right? Now, a lot of the stuff, again, maybe it was theoretical, a lot of charts, a lot of stuff that it goes from one ear to the other, a lot of confusing stuff. But again, it's information that we're going to have available. We put in the computer, we plug in, we're going to get all that to be able to use in order to be able to do our calculations. Now you say to yourself, do I need to hear all this stuff? Yeah, maybe not. But okay, the array orientation. Okay, when you put similar to the sun's position, now you got to put what? The array orientation to be able to do what? Meet the sun's position, so you get the maximum. Okay, so you have a couple things. So you have the array tilt angle, which is the vertical angle between the horizontal and the array surface. Okay, so you have the array surface and the horizontal. We call that the tilt angle, and we have the azimuth angle. This is the stuff that you have control over it. Okay, which is the horizontal angle between the reference direction, typically what? Due south, and the direction of the array faces. So when you look at this thing now, in a practical sense, you would have, this is your tilt angle, this is your surface in here, facing south, orientation. This is your sun shining in here, direct radiation, and now you have to generate this tilt angle in here, and as well position your azimuth angle in here in order to set up your array in here. And this becomes a practical thing. Now, ideally what you want to do, ideally what I like to do is what? Take the panel here and make it what? Follow the sun's position. So at all points in times, I have the sun what? Right perpendicular into what? Into the mine. Can I do that? Certainly you can do it if you have a tracking system. So if I can track it for what? For maximum power output. Since I don't have it, what do you guys practically do? Find the best spot. Some of you, what you practically do? Well, you just, if this side of the house, it's facing what? South. Just stick a panel there, whatever the direction is. Do you ever adjust the actually panels? Or you just go directly to the actually structure, just leaving a certain amount of gap. Come on, we have solar guys in here. What do you do in a slanted seal? You pick up a location. What do you do with the panel? Huh? Do you do if you have, for example, a cathedral type of a house, not a flat roof. A flat roof, actually, you can adjust the tilt angle once you step. But do you do anything in a cathedral type of roof? You just put the panels there, and you just leave equivalent space from one location to the other. You don't do any tilting. No. Okay. Nice. With this idea, well, what happens eventually is what we do in practice. We set up the tilt angle. We set up actually the azimuth angle. We bolt them down, and we're done. Okay. Maximum or actually best performance that we can get. But ideally what you want to do is actually if you could vary that. Now there are now that I should go and change the tilt angle in the winter and the summer to get maximum performance out of it. Well, we'll talk about that when we do a design here, okay? So this is what we mean by the tilt and the azimuth angle. Okay. Now, if we have a certain type of a system, that we have a specific type of energy need, we can do that, and we can do what? We can change the angles, we can change the actually tilt angles in the winter, and change it what? In the summer. We go physically up there, okay? Sometimes, to maximize the summer energy production, the array should be what? Mounted a smaller tilt angle, take advantage the high arc of the sun through the summer sky. That's probably good in the summer if you have, utilization of systems for cooling loads. And if you want to maximize the winter performance, what do? You make the angle what? At a graded tilt angle to receive what? More energy, because the sun is low in the winter. The whole sun's position with respect to the earth, we talked before, is just for these stupid conclusions in here, okay? Yeah.
What's the percentage between the winter and, if you're going to get up on the roof and adjust your tilt angle, what percentage of power
you're going to lose? That's a good question. It turns out
10%, 15% extra if you go up there seasonally and adjust the panels, or you're going to get 2%?
Well, two things. One is the need. The other thing is the actually, I think it could go as much as 30%. But don't forget, now it depends on the size of the system you have.
Yeah,
if you have a 3 kW,
fixed, so you're going to gain 10%, 20%, 30% per cell by adjusting the angle. That's what I'm talking about.
Folks said 40%.
That's optimal.
yeah. Depending, but see what happens is, the book says 40%. You can get in the practice, because there are all the types of losses that you associate with that. But typically, you can get as much as 30%, maybe 4%.
So you're telling me your system can be 30 to 40% more efficient if you vary your tilt angles?
Yeah, well, because of the position of the sun relative. Yeah, but you go, now what is the average cost of the maintenance contract that you will have to go up there and start tilting all those panels up there?
Zero. I'm doing it for myself.
For your house? Well, put a tracking system there if you do it for yourself. There's a lot. It's everything. When you do the economic analysis up there, it sees what it pays. Now, you go at somebody's roof, in Walmart or something like that, and start adjusting those things. Because, adjusting the tilt angle, it may be a task of itself. Excuse me?
I could think that would be pretty easy.
The question was, just in case you did not hear it, says, what's the percentage, what's the benefit by changing the tilt angle? And the benefit, the performance can be as much, 40% the book says, but I would say about 30%. It's pretty much.
They don't manufacture, maybe you could buy the bracket where you could actually, put it up.
Yes, yes.
It's easy and kind of clear.
You
like a ladder.
The question was, listen guys, the question was whether actually you're changing the tilt angle to improve the performance between the winter and the summer. The whole thing I said before that we got all of us confused, the whole thing is, the sun's rotation and inclination and all this stuff was because you wanted to do why you wanted to know that this is because you have to set the panel a certain tilt and azimuth angle.
You made a good point by adjusting all of them. What's the time and effort that's going to take?
Right. If you have a small system, the question was there, and the answer is yes. It improves the performance because pretty clearly, the angle determines the amount of radiation you're going to get. So therefore, you're going to get better system performance, guys. So, or you don't do it. Now there are systems. For example, in the concentrating systems, obviously you want to make sure you move those guys up here to be able to focus in the max. So you have to have this. In a typical, flat system, you pick up the best angle and you weight the benefits for it. If you want to turn your house into a science project, you go up there and you change it. 30%. 5 kW system, how many panels? You have